Hello, everyone. I'm glad to be here to talk to you again today. The topic is still fiber. So, I have one more thing I want to cover. I'm sure I'll probably come back to it later because fiber is such an important topic. But today we're going to talk about fiber and kidney toxins. So, let me share my screen with you. And y'all know I usually have a hard time, but I think I did it pretty good that time. Okay, here we go. Fiber and kidney toxins. Okay, so when we talk, the gut and the kidneys interact. Okay, so I talk, if you've seen other presentations I've given, I've talked some about the gut and the kidney and the heart and the kidney and things like that. But remember that your whole body, it works together. So, in the gut, there's several toxins that can be made in the gut. They're made from your gut microbiome. So I also have videos about that, about the gut microbiota. But basically, you just have bacteria in your gut, and those bacteria produce things. And so some people have bacteria that can produce kidney toxins, and it kind of depends on how you eat to determine how much of those you make. But there's more than this. But the three that are mostly in research are indoxyl sulfate, p-cressyl sulfate, and trimethylamine oxide, N oxide, which is TMAO, is what we'll call it, which is what most people call it. So indoxyl sulfate. We'll start with this one first. So indoxyl sulfate, again, is a metabolite of intestinal bacteria. That just means it's something that the intestinal bacteria made in your body. All of these are made from dietary protein. So, and certain amino acids in that protein. So, people who eat diets high in animal protein in particular will produce these toxins more than someone who eats a plant-based diet. Also, the amount of protein matters. Normally, the kidneys would clear these toxins, including indoxyl sulfate, but when the kidneys aren't working as well, it's not cleared as well. So again, it's a metabolite of protein. That's a tryptophan is just an amino acid, and it's processed in the gut after eating protein-rich foods. So what does this do? What happens with the kidneys when we have high levels of indoxyl sulfate? So, high concentrations are associated with increased progression of chronic kidney disease, which we're trying to prevent. It will stimulate glomerular sclerosis. What is that? So, sclerosis, fibrosis, that's scarring. We don't want scarring in the kidneys because when the kidneys scar, that means that those nephrons that are scarred, they don't come back. So, what is glomerular scarring? That is in your kidneys, you have nephrons, which are functional units. And in those functional units, you have glomeruli, which are the filtration portions of those functional units. So basically, it's like this right here, that little bundle of blood vessels, that's the glomerulus. Anyway, it gets scarred and then it doesn't work anymore. It's also a tubular toxin. So you also have tubules in the kidneys, and it can cause cellular death of those tubules. It can cause interstitial fibrosis. It can cause scarring in between the spaces of the tubules and the capillaries. So it really is pretty damaging to the whole kidney. It also affects the heart. So I always talk about the heart when I talk about kidney disease. And I tell people if you're a kidney patient, you're a heart patient. Because cardiovascular disease is the major cause of death in people with chronic kidney disease, accounting for about 50% of all deaths. It's also people who have chronic kidney disease are about 30 times more likely than the general population to develop cardiovascular disease. So it's a pretty big deal. So indoxyl sulfate increases oxidative stress, that's inflammation related to vascular dysfunction. So oxidative stress in the veins and increase the risk of cardiovascular disease. It speeds the progression of cardiovascular disease in people with chronic kidney disease. It inhibits what we call nitric oxide production. You don't want to inhibit this. So nitric oxide is a gas in the blood vessels, and you always want your blood vessels to do like this, to be real pliable, and nitric oxide helps that happen. Foods that are high in nitrates, like beets or leafy greens, will help your body make that nitric oxide. But when you produce these toxins, it's going to inhibit the production and the survival of this nitric oxide. And so your blood vessels can become stiff. It's also independently correlated with aortic calcification and vascular stiffness. We already talked about inflammation with the heart. It increases oxidative stress. So that means it increases inflammation, but it will also decrease antioxidant activity. For example, glutathione, which is an endogenous antioxidant, meaning that your body makes it, it will decrease the activity of that antioxidant. We don't want to decrease antioxidant activity because that helps lower inflammation. And then it can affect the brain. It's a neurotoxin. And animal studies, not human studies, but it still has value that animal studies do show cognitive impairment in people with chronic kidney disease. And I have even seen that just in people that I've worked with. They will complain about that with me. Okay. The next is p-cressyl sulfate, also a uremic toxin, also produced in the gut. It's a biomarker for chronic kidney disease because the kidneys don't clear it as well. So it can kind of help us. It could be used as like, we don't use it much, but you could use it as a biomarker to show that kidney disease is actually present. It does also damage tubular cells, and it does lead to scarring. So same thing. It affects cardiovascular disease in patients with chronic kidney disease, and it's a predictor of cardiovascular disease and all-cause mortality in dialysis patients. Now that's just a study I included in here. I'm mainly though in this presentation, I'm mainly talking about pre-dialysis or chronic kidney disease. Um, it does the same as indoxyl sulfate. It decreases the glutathione level, so it's going to decrease antioxidant activity and increase oxidant or inflammatory activity. And it triggers inflammatory cytokines. So those are just inflammatory cells that are involved in the renal scarring. So we definitely want to keep this down. Then TMAO. So TMAO is a little bit, it's really more common in the cardiovascular space. They talk about it more there, but it's very relevant in the kidney space. This is produced in the gut after consumption. People who consume foods that have a lot of choline and carnitine, like meat, dairy, eggs, things like that. And so it is also a uremic toxin, even though it's more talked about in the heart space. Now we talked about that certain foods will cause the body to produce this toxin, but you have to have the gut bacteria present. Once you eat those foods, you have to have certain bacteria present for this to be produced. So it's interesting if you took someone, so let's say I have a person who's completely vegan and that's all they eat all the time, and then you fed them a one-time steak, they wouldn't produce TMAO because they don't have the bacteria in there to produce it. Why? Because they haven't been feeding that bacteria. They have been feeding bacteria from plants. So whatever you feed is what's going to grow in your gut. And if you starve, if you don't eat plants, then those will not grow in the gut. So you definitely, it's not just about a one meal thing, but it's about over the long haul. What type of bacteria am I feeding in my gut, and what are those bacteria producing? And we want the ones that are producing good things to thrive, not the ones that are producing kidney toxins to thrive. Um, so we've talked about all of this. It is associated with mortality in chronic kidney disease patients. Um, it is a risk for major cardiac events. I have even heard some cardiologists drawing levels of TMAO. Um, it will foster inflammatory cells in the plaque of the walls of the arteries that attach to LDL cholesterol. So if you have too much LDL cholesterol floating through the arteries and these inflammatory cells, there's a lining, an endothelial lining, they will attach to that LDL. And it begins to build up in that lining. That's where you're getting the blockages in the arteries and veins. It causes increased production of foam cells, which is also part of that process in the lining of the arteries and veins that leads to blockages. All right. So now let's talk about how we're going to lower it, because we know we don't want these things. How are we going to lower it? So there's many ways to do it, but today, like I said, we're talking about fiber. So we're going to talk about dietary fiber from food and fiber supplementation. So dietary fiber, if you remember when we were talking about potassium, and if you haven't seen that video, you can go find that one, but it has a laxative effect so that there's an increased transit time in the gut and you're going to excrete these toxins faster, the same way kind of we talked about with potassium, you'll excrete potassium faster. So it also improves the intestinal barrier. So this is something we haven't talked about yet. In your intestine, you have this barrier and you want it to be really tight, these tight junctions. And inside these tight junctions, there's a mucosal layer. So those bacteria in your gut want to feed on fiber, but if you do not feed them fiber, they will eat that mucosal layer, and you can start to get this separation of those tight junctions to where now these toxins are getting out into the bloodstream. And so we don't want that. We also we want a tight gut wall, but inside the gut, we want certain bacteria. We want saccharolytic bacteria because these are anti-inflammatories bacteria. They produce things like short-chain fatty acids, which are actually have antioxidant abilities. So a high fiber diet, resistant starch is going to feed this type of bacteria. Where does fiber come from? We've talked about it before. It comes from plants. So does resistant starch. Proteolytic bacteria is inflammatory bacteria. It is going to produce these kidney toxins. We don't want that. A high fiber diet will suppress these bacteria to keep them from doing that, but it also high animal protein intake promotes proteolytic bacteria. So again, we're back to plants. And then this slide is just showing you what I just said. It's just a kind of a picture, a schematic of it. So you're going to see the proteolytic bacteria. If you go to the right, you'll see those kidney toxins. And then here, the saccharolytic, you're going to see lower inflammation, which is anti-inflammatory to preserve the kidney function. So it's just basically a picture of what I just said. Okay, so that's food. Now, what about fiber supplementation? So there has been some research on fiber supplementation, and if you look at for p-cressyl sulfate and indoxyl sulfate, inulin and pea whole fiber at around 10 grams a day showed significant lowering in p-cressyl sulfate. And then resistant starch showed significant lowering. That's more food in the indoxyl sulfate. So you could add some supplements, some fiber supplements, but also diet. So it's a both and. So you can't eat a low fiber diet and just take supplements. I'm a food first dietitian, so I always say diet first, but you could supplement with some of these other fiber supplements and bring down some of these kidney toxins. And then for the TMAO, the research is really just showing that people who eat plant-based diets, they just don't produce that TMAO like people who eat animal protein diets. So what are our takeaways? We're going to eat a whole food plant-based diet, focus on fiber. Remember, just like I said in the other videos, if you don't eat a lot of fiber now, please go up slow because it can cause some GI distress if you don't. And then one thing I haven't talked about is just to be sure to drink enough water. If you don't have a fluid restriction, if you're a CKD, not a dialysis patient, dialysis, please go with what your center is telling you on your fluid intake. But be sure to drink enough water because, again, that can cause constipation if you eat a lot of fiber and don't drink water. And that is it. These are my references. I am going to stop sharing now. And I hope that was super helpful. And if you feel like you still need help and want to work with me, if you go out to plantfedwellness.com, there are 2 links. You can either work with me for insurance, which there's a link for that. And then there's a link for self-pay as well. And then if you would like to learn more about different topics for kidney disease, if you go out to Amazon, you'll find my book there. It's called Plant Fed Kidneys, and it's for the patient. Please be sure to get that one because it's designed especially for you. Lots of charts in there, things you can reference back to when you get labs back and things such as that. So anyway, I hope y'all all have a great day, and thanks for taking time to listen to this.